Welcome to the Systems of Equations Tournament of Champions Super Smackdown! Pew, 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 pew! Stepping into the ring in this corner, we've got solving systems by graphing. In this corner is substitution. In this corner, combination, aka elimination. In this corner, systems with no solution. In this corner, systems with infinite solutions. Wait, that's too many corners. My brain is breaking. But who cares? The crowd's going wild. Our systems are out for blood. Let's get ready to rumble. Hello, my friends. How are you? Welcome to Class 8 of Unit 5, Solving Systems Redux. For today, you have a problem set to complete for me. You are in no way obligated to watch this video or to take notes. If you don't, I will be sad and lonely, but that's okay. I'm a big girl. I can handle it. So, if you find yourself as somebody who needs a little bit more support, wants to see a couple more examples worked out, here's that resource available for you. And if you're not, congratulations, do your problem set. So, at no point will I pause the video. At no point will I say, stop and pause yourself. I'm going to continue to work. But I encourage you, as I often do with these types of videos, before you see me work out the solution, take 2 minutes, take 3 minutes. Give it a shot. Try your best, see what you come up with. Once you think you've got something, come back and check your answer with me. For our first example, thinking about where we started off the unit, let's say that I want to verify if this ordered pair, -4, 3/2, is the solution of this system of equations. In order to answer this question, I first need to know, well, which value is taking the place of which variable? I have a j and a k. J comes first in the alphabet, so in my ordered pair notation, -4 will take the place of j, 3/2 will take the place, not of 4, but of k. All I need to do to verify if something is a solution, fancy word for check my solution, is do some substitution. J is -4, so I'm going to take my first equation, j minus 2k equals -7. J is equal to -4, and then I have -2 times k, which we've established is 3/2, equals -7. And in my second equation, I have -5j, which is -4 from our ordered pair, minus 4k, caught in 4k. I have k, though, being replaced by 3/2, equals 14. By definition, if this is the solution, it should make both equations true. So as long as I get 2 true statements, I'm happy. -4 minus 2 times 3/2. Notice I can undo this times 2 and this division by 2, so I'm just left with -3 equals -7. -4 minus 3 is equal to -7, so it makes our first equation true. For our second one, -5 times -4 is 20. And then I have minus 4 times 3/2. I can do the same thing, cross-simplifying 4 and 2. I can get to 2 and 1. I have 2 times 3/1. 3/1 is 3. 2 times 3 is 6. 20 minus 6 is equal to 14. Yes, this is a solution to the second equation. Therefore, it makes both of the equations true. It is the solution to my system. Very nice. Next up, let's do some graphing. I have x minus y equals 4 and 4x plus y equals 1. Again, I know that to solve a system means to identify the point where the lines intersect. If I want to graph these lines, the easiest way to graph a line, I could make a table, but I'm going to take both of my equations and rewrite them in slope-intercept form. In order to do so, I need to get y by itself. So taking our first, x minus y equals 4, to get y by itself, let me begin by subtracting x from both sides. That tells me that -y is equal to -x plus 4. And then if I divide each of my terms by -1, or multiply each of my terms by -1, I could show that y is equal to x minus 4. Cool. For our second equation, I have 4x plus y equals 1. Again, my goal is to isolate y, so let me subtract 4x from both sides. When I do so, I find that y is equal to -4x plus 1. Cool. For my equation on the left, I'm going to do it in blue. Because I am in y equals mx plus b, slope-intercept form, I know that the slope is the coefficient of x, So the slope is 1, which I'm going to choose to represent as a fraction 1 over 1, so I can use my rise and run. The y-intercept of this line is negative 4. So to graph, I'm going to start by plotting my y-intercept at 1, 2, 3, negative 4 right here on the y-axis. Using my slope of 1 over 1, I have a positive slope, so let's say I go up 1 and over to the right 1. I would land at this point, which is 1 comma negative 3. To find my third point, I'll again go up 1 and over to the right 1. This point is 2 comma 2. Connecting my 3 points with a line, there is the graph of y equals x minus 4. I've got y equals negative 4x plus 1. Again, I'm in slope-intercept form. So the coefficient of x, which is negative 4, which I'll choose to write as 4 over 1 because I want to use my slope to find some points. And my y-intercept is 1. So on my y-axis, I'm going to count up to 1 over here. So here's the point 0, comma 1. And again for my slope, so I have a negative slope. Let's say that I go down 1, 2, 3, 4, and over to the right 1. Would you look at that? It looks like that point there, 1 comma negative 3, is going to be the solution to my system. Let me find one more point for good measure on my graph. Say that I go up 4 this time, 1, 2, 3, 4, and over to the left 1. I should have another point right over here at negative 1, comma 5. Connecting my 3 points with a line, we're going to pretend that this line is straight and perfect. Although then again, being straight is overrated. So I've got this guy here. It certainly looks like this point, 1 comma negative 3, is my solution. To make sure, I'm just going to check. So checking in our first equation, I know that x minus y is equal to 4. We've identified that x here should be 1 and y should be negative 3. Doing some substitution, that means that 1 minus negative 3 in my first equation should be equal to 4. 1 minus negative 3 can be more simply written as 1 plus 3. And yup, 1 plus 3 is indeed equal to 4. And finally, I don't know if you can hear the cop cars outside. They are finally coming for me. And then 4x plus y equals 1. I know that I want to do some substitution, so I'm going to take 4 times x, which we've identified as 1, plus y, which is negative 3, equals 1. From here, 4 times 1 is 4. Plus negative 3 can be more simply written as minus 3, equals 1. 4 minus 3 is equal to 1. Congratulations, we have found our solution of 1 comma negative 3. Very nice. From here, let's do some substitution and elimination. W equals negative 8v plus 2. 2v plus w equals negative 10. If you want to pause, here's your chance. Thinking strategically, notice that w is already by itself. I'm going to choose to use substitution and plug my top equation into the equation on the bottom. From here, that means if I replace w with the equivalent statement of negative 8v plus 2, I would get that 2v plus negative 8v plus 2 is equal to negative 10. From here, I've got 2v plus negative 8v can be more simply written as minus 8v. Then I have plus 2 equals negative 10. From here, I've got some like terms I can combine. 2v minus 8v is negative 6v. And then I have negative 6v plus 2 equals negative 10. To get v by itself, let me start by subtracting 2 from both sides. Negative 6v is equal to negative 12. And last move, let's divide both sides by negative 6 to get v equals 2. From here, I know that v equals 2. I need to find the value of w. Strategically, the wisest place for me to do so would be by substituting into that top equation over here. My goal is to get w by itself. Notice that in that top equation, w is already isolated. So I have w equals negative 8 times 2, which is negative 16, plus 2 at the end. That should tell me that w is equal to negative 14. Beautiful. As an ordered pair, if I so wished, V comes before W in the alphabet. Therefore, in my ordered pair notation, the 2 would come before the negative 14. Lovely. Next up, 3p plus 5q equals 26, and p plus 2q equals negative 6. So I chose to solve the one above by substitution. For the sake of switching it up, let's do elimination for the bottom. I need to find a common multiple between either the p's and the q's. In order to do so, I think probably the easiest choice to make here would be to multiply the entire bottom equation by 3. So I'm going to take each of my terms and multiply by 3. Doing so, my new system of equations becomes 3p plus 5q equals 26 on the top. 3 times p gives me the 3p that I want. 3 times negative 2q gives me negative 6q. And finally, 3 times negative 6 gives me negative 18. I have 3p and 3p that I can eliminate. Because they have the same sign, I know that I want to subtract the two of them to get them to undo each other. 3p minus 3p, that's 0. I have 5q minus negative 6q, which is 5q plus 6q. This is 11q. And on the right, I have 26 minus negative 18, which becomes 26 plus 18. 26 plus 18 is equal to 44. Dividing both sides by 11 to get q by itself, that tells me q is equal to 4. Knowing that q equals 4, I want to find the value of p. Strategically, this equation on the bottom, before I multiplied by 3, is the wisest place to do that substitution. So I know that p minus 2 times q, which we identified as 4, is equal to negative 6. Simplifying, p minus 2 times 4 is 8, is equal to negative 6. Finally, to get p by itself, we're going to add 8 to both sides. P is equal to 2. Last but not least, as an ordered pair, p comes before q in the alphabet. Therefore, 2 comes before 4 in the ordered pair. Magnificent. Next up, 15c minus 5d equals negative 20. Negative 3c plus d equals 4. Here, I did the previous one by elimination. I'll do this guy by substitution. Notice I have d without a coefficient. This will be my easiest dude to substitute in. So from here, I'm going to take this equation at the bottom and get d by itself by adding 3c to both sides. When I do that, I find that d is equal to 3c plus 4. Now I'm going to take this value of d and substitute into my top equation. That tells me that 15c minus 5d, but d is equal to 3c plus 4 from our earlier rearranging, is equal to negative 20. Doing some distributive property, I've got a negative 5 that I'm going to hand out to both the 3c and the plus 4. Negative 5 times 3 gives me negative 15c. Negative 5 times 4 gives me negative 20 equals negative 20. Look at that. 15c minus 15c is equal to 0. So I've got negative 20 is equal to negative 20. All of my variables have gone away, so I just need to ask myself, is this true? Does it cause me pain is also a good question to ask. Of course, it does, but that's okay. Negative 20 is equal to negative 20. This is a true statement. Therefore, this system of equations has infinite solutions. There are infinitely many points. In fact, any point on one line will make the other equation true. If you notice, they are in fact multiples of each other. So these are two different ways of writing the same line. Very nice. Last but not least, before our little challenge one at the end, 4m minus 3n equals 8. 5m minus 2n equals negative 11. Notice, once again, I have no common coefficients. I'm going to choose to solve this guy using elimination. I did the above using substitution. Let's switch it up. Because I have no coefficients, and because 3 is not a multiple of 2, nor is 4 a multiple of 5, I'm going to need to multiply both of my equations by some number to get to a place where I can create a common coefficient. Between 4 and 5 and 3 and 2, multiplying to get 6 out of 3 and 2 is probably the easiest option. So to turn the 3n in the top equation into a 6n, let me multiply the top by 2. To turn the 2n in the bottom into a 6n, I'm going to multiply the entire equation by 3. Doing some distributive property, on the top, my new equation will become 2 times 4m, which is 8m, minus 2 times 3n, which is 6n, equals 2 times 8, which is 16. On the bottom, 3 times 5m would give me 15m, minus 2n times 3, which is 6n that we wanted. And then on the right, negative 11 times 3 is negative 33. From here, notice that I have a negative 6n and a negative 6n. Again, they have the same sign, so I'm going to undo them using subtraction. From here, our combination. 8m minus 15m is going to give me negative 7m. Negative 6n minus negative 6n would become negative 6n plus 6n, which is 0. And finally, on the right side, I have 16 minus negative 33. That would become 16 plus 33, which is equal to 49. From here, let's divide both sides by negative 7 to isolate our variable m, which will be equal to 49 divided by negative 7. That is negative 7. Now that I know m is equal to negative 7, let's do some substitution. Looking at my two equations, it doesn't really matter which one. I'm going to choose to substitute into the bottom one because those numbers, at least to me, seem a little bit more friendly. From here, I know that 5m, but m we have identified as negative 7, minus 2n is equal to negative 11. All that's left to do is solve for n. 5 times negative 7 is negative 35. I have minus 2n equals negative 11. Adding 35 to both sides. On the right side, 35 minus 11 is the same as negative 11 plus 35. That would be equal to 24. And I had negative 2n over here on the left. Dividing both sides by negative 2 tells me that n is equal to negative 12. As an ordered pair, m comes before n in the alphabet. Therefore, I could say that negative 7 will come before negative 12 in our ordered pair. Cool. Last but not least, there are lots of cool creative questions that can be asked, and I'm kind of hyping myself up by calling this creative. But hey, everybody deserves to stroke their ego every once in a while. Let's say, for example, I asked you something like this guy. You might recognize it as a challenge question from a previous class. A line passing through the point 4, negative 1 is perpendicular to the line 4x minus 3y equals 19. I want to find the point where my lines intersect. Again, of course, if I'm finding the point where the lines intersect, what that really means is that I'm asking you to solve a system of equations. But in order to do that, I've got one equation, 4x minus 3y equals 19, but I still need to find the other equation of the line, which tells me that I need to use point-slope form. If I'm going to find the equation of a line, I need a point and a slope. Notice I've given you a point. 4, negative 1 will be our x1, y1. To find the slope, remember that I am perpendicular. The slopes of perpendicular lines are related in an interesting way. So if 4x minus 3y equals 19, let's say I want to find the slope of this line. To do so, let me rewrite it in y equals mx plus b form. Minusing 4x from both sides, I get that negative 3y is equal to negative 4x plus 19. And then finally, dividing both sides by negative 3, I can find that y is equal to 4 over 3x, again, our negative signs will undo each other, minus 19 over 3. Of course, the 19 over 3 doesn't matter because I'm just using the perpendicular line to find its slope. The slope of this line is 4 over 3. Perpendicular lines, you may remember, their slopes are negative reciprocals, which means I need to flip the sign to find my slope from positive to negative, and I need to take the reciprocal of 4/3 to get 3/4. So the slope of my line is negative 3 over 4, and I have a point, 4 comma negative 1. Let's do some point slope form. By substitution, I can say that y minus negative 1 for my y1 is equal to m, which we've identified as negative 3 over 4, parentheses x minus x1, which we've identified from our point above as 4. Cool. Simplifying on the left side, y minus negative 1 can be more simply written as y plus 1. Taking negative 3/4 and doing some distributive property, I have negative 3/4 times x, which is negative 3/4 x, perhaps trivially. Then I have a negative times a negative, so it's going to be positive. 3/4 times 4 is just 3. Right? 3/4 of 4 is 3. All I need to do, I'm going to take my y, get it by itself. Y is equal to negative 3/4 x plus 2. So here is the equation of my line. And now that I've got it, I know that I am trying to solve a system. The system that I need to solve will contain both this line, because I'm identifying their point of intersection, and the perpendicular line 4x minus 3y equals 19. Cool. All I need to do now is solve this system. If I'm thinking strategically, once again, we can notice that y is by itself here. Let's solve this using some substitution. So from here, substituting my top equation into my bottom equation, I find that 4x minus 3y, but y, of course, is equal to negative 3 over 4x plus 2. That is equal to 19. From here, let's do some distributive property. I've got the negative 3 that I can give to both of the terms inside of my parentheses. Negative 3 times negative 3/4, feel free to fact check me, should be positive 9/4 x. Negative 3 times 2 is negative 6. And then I've got the 19 over on the right. Let me add 6 to both sides. If I wanted to, I could have combined my like terms first. That's totally fine. I've got 4x plus 9/4 x equals 19 plus 6, which is equal to 25. From here, I've got 4x and 9/4 x that I need to combine. In order to do so, I need a common denominator. So I've got 4 over 1 plus 9 over 4 over here to the side. I need to rewrite 4 over 1 as a fraction of 4. 4 over 1 is equivalent to 16 over 4. 16 plus 9, interesting, we've just noted, is 25 over 4. So this is equal to 25 over 4x equals 25. To get rid of multiplication by 25 over 4, I can divide by 25 over 4, which is the same as multiplying by the reciprocal of 4 over 25. On the left side, multiplying by the reciprocal will just give me 1x. And then on the right side, 25, I can imagine this if I want to, as 25 over 1 times 4 over 25. Notice 25 in the top, 25 in the bottom. These guys can cancel out. I'm left with 1 over 1 times 4 over 1. X is equal to 4. And finally, 4x minus 3y equals 19. If I know that x is equal to 4, I'm going to do some substitution. I would say the wisest place to substitute is the equation on top. So I know here that y is equal to negative 3/4 x, which we've just found is 4 plus 2. Negative 3/4 times 4 is negative 3. Negative 3 plus 2 is negative 1. Therefore, y is equal to negative 1. So interestingly enough, we just did a whole bunch of work to show that the point 4 comma negative 1 is in fact our point of intersection. And if you look back up above, we found that 4 comma negative 1 was the point on our line.